Welcome. In this mini lecture, we're going to cover the second part of Chapter 4. We're going to look at two more examples of proof, and in this instance, we're not going to write all the sentences. We're going to look at how we outline a proof before we write sentences. So, here's our proposition. If a is an odd integer, then a squared plus 3a plus 5 is odd. So, our proof, again, we need to start by defining our variables. So we will suppose a is an odd integer. Now, the definition of odd tells us that a can be written as 2k plus 1 for some integer k. Then we're interested in looking at a squared plus 3a plus 5. Well, this becomes 2k plus 1 squared plus 3 times 2k plus 1 plus 5. Expanding everything out, we'll get 4k squared plus 4k plus 1 plus 6k plus 3 plus 5. Now, we're going to try to get it to the form of 2 times an integer plus 1. So, what I'm going to do here is I'm going to observe that 3 and 5 together will give me an even number, and this 1 will give me the 1 that I need. So, I can write this as 2 times a 2k squared plus, well, 4 and 6 will give me 10k. Because I'm taking out a 2, we'll have a plus 5k. And then that 5 and 3 gives me an 8, but we'll write that as a plus 4. And then we'll leave that plus 1. Now again, we know that this has to be an integer because the integers are closed under addition and multiplication. So when we put that together, we get an integer. So now we've written a squared plus 3a plus 5 as 2 times an integer plus 1. Now I haven't written all the sentences like I did in the previous one. This is just an outline. This is the scratch work. But from this, it's easy to go and finish writing out the sentences that are needed to complete the proof. I'll leave that to you to do on your own as practice. So let's look at another one. This will be our first one using the divides notation. So we have the proposition, if A divides B and C divides D, then AC divides BD. So again, we're just going to outline it. And we'll begin with, we know that A, B, C, and D have to be integers because our divides is only defined for those, such that A divides B and C divides D. So, A divides B. If we go back and look at the definition, we know that this means that B has to be able to be written as A times another integer k. Similarly, C divides D means that we have to be able to write D is equal to C times, pick anything other than A, B, C, D, or K. In this case, I've chosen Q to be my other integer. Now, I need to look at AC. I want AC to divide BD. So we'll actually start with BD. Well, BD we know is AK times CQ. Because we know that the associative and commutative properties hold for integers, we can rewrite this as AC times KQ. Again, KQ has to be an integer. So since we're able to write BD as AC times another integer, that tells us, in fact, that AC has to divide BD. So again, I didn't write all of the sentences. This is the outline of what the sentences will become. So how do you turn all of this into the sentences? Here it is typed up in LaTeX. And note that in LaTeX you want to use the proof environment. So you can begin your proof, type your proof, and of course anything we begin, we have to end. So using this environment and turning what's above into sentences, we have the following proof. We let A, B, C, and D be integers such that A divides B and C divides D. By definition of divides, we may write B equals AK and D equals CM for some K and M in Z. I used Q above. Again, the choice of name doesn't matter as long as it's something you haven't used before. Now, when we look at BD, we get AK times CM, rewriting AC times KM. This piece, the commutative property of integer multiplication, to get that, you add a tag inside of the align environment. So this was done using the align star environment. Since the integers are closed under multiplication, we know that Km is an integer. Therefore, by the definition of divides, AC divides BD, and we're done. And the proof environment automatically puts a box at the end of your proof. So, now you should practice going through the exercises that have been assigned, create a proof outline, and then use that proof outline to write the proof using actual sentences. If you have any questions, make sure to come see me in office hours. Thanks. Have a great day.